All right, let's take a look now at the third part for 7.4, actually dealing with the binomial theorem, which we are going to define on this video. So let's just take a look at some things that we've learned from the first two parts about expanding x plus y raised to the n power. So we know the number of terms are going to be n plus 1. Okay, again, the number of terms. So x plus y, we know raised to the 0 power, that was just one term. X plus y raised to the first power, so our n is 1, that ends up being x plus y. So there is actually two terms when we expand it all out. So whatever our exponent is, so x plus y squared, we know that is x squared plus 2xy plus y squared. There are three terms here. So whatever our exponent is, add 1 to it. That will tell us the number of terms in the expansion. First term is x raised to whatever our exponent was, and the last term is y raised to whatever our exponent is. As we move to the right, x decreases by 1 and y increases by 1. The sum of the exponents of x and y are always going to add up to be n. And then the coefficients are from this n choose r formula, where it's x raised to the r and then n minus r. So the actual binomial theorem, the coefficient of the term x raised to the r, y raised to the n minus r, or we can write it as n choose r, is this n factorial, r factorial, n minus r factorial. Now, because of symmetry, we could also write this way, all right? Because I know the sum of my exponents is going to be n. So now if I say my y has an exponent of r, x has to have an exponent of n minus r. So I could also rewrite it like this. The denominators look different, but they're just switched around. And because they're multiplied, it doesn't matter. 5 times 2 is the same as 2 times 5. So the binomial theorem, if we were to expand x plus y raised to the n power, it would look like this. So this looks long and nasty, but it's pretty intuitive. It just follows a pattern. This first term is x to the n, and we've established that the very first term is just going to be x. I mean, it's y to the 0 power, which is just 1, so we're not writing that. I don't have an n choose anything on the first one that's written, because really it's n choose 0. Because my n and my 0, so it's n choose 0. N choose 0 is 1. So it's 1 times x to the n times 1. So you can just write it as x to the n. So you can see a pattern, n choose 0, n choose 1, 2, 3, all the way out till you get to r, whatever your final exponent's going to be. So this is officially the binomial theorem, how you expand a binomial x plus y raised to the n power. Let's actually go back to that just for a second. And again, looking at the exponents, we can see the exponent on x decreases by 1 every time. So this is n minus 1, n minus 2, n minus 3 is decreasing, and then y is increasing. It was y to the 0, y to the first, y squared, y cubed. So again, it looks intimidating, but it's just following a pattern. Let's actually apply the binomial theorem to expand x plus y raised to the 9th power. So I know my first term, it's going to be 9 choose 0, x to the 9, y to the 0. Well, n choose 0 is just 1 times x to the 9th times 1. So this is really just x to the 9th, but we've established that before. But to stay consistent with our pattern, now we're going to have this plus 9 choose 1. Take 1 away from our exponent, so this is x to the 8th. Add 1 to the exponent, so this is y. Plus 9 choose 2. X to the 7th. Y to the 1st. Or I'm sorry, y to the 2nd. plus 9 choose 3, x to the 6, y cubed, plus 9 choose 4, x to the 5th, y to the 4th, plus 9 choose 5, x to the 4th, y to the 5th, plus 9 choose 6, x to the 3rd, y to the 6th, plus 9 choose 7, x squared, y to the 7th, plus 9 choose 8, x to the first power, y to the 8th, plus 9 choose 9. So this is another one. 9 choose 9. If I had 9 tennis balls and I take 9 at a time, there's only one way I could do that. So that's really 1. And then x is going to become x to the 0 power, and then y to the 9th. And so this last term I would simply write as y to the 9th, which follows our pattern where we know the first term is going to be x to the 9th, the last term is y to the 9th. To work all of this out, this 9 choose 1, 9 choose 2, 9 choose 3, we have to keep going with it. So if I were to work this out, 9 choose 1, if I were to do that, so 9 choose 1, I have to go back to my factorial piece where it's 9 factorial all over my exponents, which is 1 factorial times 8 factorial. All right, so 9 factorial divided by 8 factorial. This would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of these go away, and all I'm left with is 9. So we do have to continue simplifying each and every one of these, and it get very tedious, so I won't give you as many problems. But this 9 choose 1 is really 9. So this term is 9x to the 8th y. So I have x to the 9, 9x to the 8th y. This term becomes 36, x to the 7th, y squared. This becomes 84, x to the 6th, y cubed. This becomes 126, x to the 5th, y to the 4th. This is also 126, x to the 4th, y to the 5th. And this one becomes 84, x cubed, y to the 6th. This becomes 36, x squared, y to the 7th, 9x, y to the 8th, and then just plus this one, which is y to the 9th. But this is still part of Pascal's triangle. It's just further down. We can see that there is symmetry. We had a 9 to start with, so I'll go green. So we had this 9 and this 9. And then we went 36, 36, 84, 84, 126, 126. So those will match up as your coefficients when you're working through these. So like I said, these ones can get a little tedious, but it's just following a pattern and you will be able to get to the right numbers. Let's take a look at one more. Now let's mix it up. Let's use A's and B's instead of X and Y. And in this one, our Y is actually negative B over 2. All right, so if we were to expand this out, we know our first term is going to be a to the 5th, and all the way down at the end, it's going to be b over 2 raised to the 5th. Pay close attention to this sign. This is a negative, and so we've been treating everything as x plus y. In this one, let's treat it as x plus a negative b over 2. So that negative b over 2 is going to be our very last term raised to the 5th power. All right, so if we were to expand this one out, a to the 5th, 5 is my n, and so I'm going to do 5 choose 1, and this will be a to the 4th, and then a negative b over 2 raised to the 1st power. So a to the 4th, and that term raised to the 1st still gets me my sum of 5, plus 5 choose 2, a cubed, negative b over 2 squared plus 5 choose 3, a squared negative b over 2 cubed plus 5 choose 4, a negative b over 2 to the fourth plus negative b over 2 raised to the fifth power. Working this out, I'm going to have a to the fifth, 5a to the fourth, and then my negative b over 2. So 5a to the fourth times the negative b over 2 plus 10a cubed negative b over 2 squared plus 10a squared negative b over 2 cubed plus 5a negative b over 2 to the fourth plus negative b over 2 to the fifth. You can take this one step further. A to the fifth stays. 5a to the fourth times a negative b over 2 makes this a negative 5 halves because we're multiplying all the way through. A to the fourth b. Plus, on this one, this up here, negative b over 2 squared would be negative b squared all over 2 squared, so it's really over the fourth. And so this is 10 over 4, which simplifies to 5 halves. So this is 5 halves, a cubed, b squared, and it's plus because we're squaring a negative value. Continuing on, this would be now a negative because it's a negative value cubed. So this is negative 5/4, a squared, b cubed, and this is final simplified form, plus 5 over 16, ab to the fourth, minus 1 over 32, b to the fifth. That would be the final expansion of a minus b over 2, all raised to the fifth power. So that's it. Take a look at part 3 now in Math Excel. I know these ones are tedious, so I'm not going to give you too many problems to do, but work through the problems and let me know if you have any questions.